thought we'd go over a short video on how to multiply fractions. So I've got several problems set up. Our first one says let's multiply 2/3 times 3/8. Well, the general rule for multiplication tells us that we multiply the numerator times the numerator to get our new numerator. 2 times 3 is 6. Denom times denom, 3 times 8 is 24. And then we look at it, and if we can reduce it to an equivalent but smaller fraction, we do. I see that 2 would go into it, 3 will go, but actually 6 will go evenly into both. It has to be one number, a 6, that will go into top and bottom evenly. So 6 divided by 6 equals 1. 24 divided by 6 equals 4. I look at my 1/4. There is no number that will go evenly into both 1 and 4. 1 will go, but it would be just 1/4. So we have reached lowest terms. So that's one way to do it. And it works really well like this when we have small numbers. When we have larger numbers, we come up with a big answer, and then we have to spend a lot of time reducing. So I always suggest that students do cross-reducing before they multiply. So it looks like this. So we have a numerator 3 and a denominator 3. It's as if we have 3 over 3. And we know that we can divide 3 into both of those. I can divide 3 into top and bottom. So instead of having it stacked like this, I have it a little bit as a cross product. So here's a 3, numerator, denominator. And what I'm doing is I'm dividing numerator and denominator by 3, just as I did here. When I have 3 divided by 3, I get 1. 3 divided by 3, I get 1. Same thing. 3 divided by 3 is 1. 3 divided by 3 is 1. Now I look at my 2 and my 8. I pretend in my brain that it's written like this, 2/8. Well, I see right away that 2 will go both into the numerator and to the denominator. So I'm going to divide by 2 and divide by 2. The rule states that I must divide both numerator and denominator by the same number. So I can't divide this 8 by 4 and the 2 by 2. It has to be the same. So I'm going to divide 2 by 2, and I get 1. 8 divided by 2 gives me 4. Now I'm going to take my new numerator times my new numerator. I have 1 times 1 is 1. My new denominator times my new denominator. 1 times 4 is 4. So I get the same answer whether I do the cross-reducing or I don't do the cross-reducing. Let's look at number 2. It's a little bit larger number, so I hope you see the value in the cross-reducing. So we could go ahead and multiply 5 times 12, and that will give us 60. And then I could multiply 25 times 9, so I'm going to come over here in my scratch paper. 5, 18, 20, 225, and I'm going to come up with 225. And then I know I can reduce them. They both end in a 5 or a 0, so I know I can divide top and bottom by 5. 60 divided by 5 equals 12. 225 divided by 5, well, I'm going to have to use scratch paper. 5 won't go into 2, but 5 will go into there 4 times. 5 goes into here 5 times, and I come up with a denominator of 45. Now I have 12 over 45. Well, I still can reduce that. I can divide top and bottom by 3. 12 divided by 3 gives me 4. 45 divided by 3 gives me 15. I look at my 4/15. 2 will go into the 4, but 2 won't go into 15. 3 and 5 will go into 15, but neither of them go into 4. So there is not one number that will go evenly into top and bottom. So I've come to my final answer of 4/15. That was a lot of work. So I always suggest that we do the cross-reducing. Instead of reducing here and taking all this time, we could multiply incorrectly, we could divide incorrectly, besides the time it takes. I always suggest that we reduce before we multiply. So if I have 5 over 25, you may think of it like this. And what we'll do is divide 5 into numerator and denominator. So 5 goes into 5 once, 5 goes into 25 5 times. Some students rewrite the fractions. If you do, it would look like this. So I've done this pair. I look over here at my 9 and my 12. Well, let's see, what would go evenly into both? Oh, divided by 3. 3, divide by 3. So 12 divided by 3 gives me 4. 9 divided by 3 gives me 3. So I'm going to put my digits here. You can rewrite it, and then you have 1 times 4 equals 4. 3 times 5 is 15. Or I usually just leave my work here and multiply 1 times 4 gives me 4. 3 times 5 gives me 15. Either way, we're coming up with 4/15, which is the same answer we got when we went on the long way. Let's look at number 3. This is 25/12 times 4/20. I don't want to do all this long multiplication, so I'm going to look for some cross-canceling opportunities. I only can do a pair. Sometimes I can do this pair and not this pair. That's okay. So I'm going to look at my 25 and my 20. I know from divisibility rules that 5 will go into anything that ends with a 5 or a 0. So I'm going to divide by 5, divide by 5. 25 divided by 5 gives me my new number 5. 20 divided by 5 gives me 4. I look at 4 and 12. Well, the only thing going into 4 is 4, and 4 will go into 12. So I am going to divide by 4 for both of them. 4 divided by 4 gives me 1. 12 divided by 4 gives me 3. And I'm left with my new numerator times my new numerator. 5 times 1 gives me 5. 3 times 4 gives me 12. I look at my 5/12. There is nothing common. 5 will go into 5, but it won't go into 12. There is no number that will divide evenly into both the numerator and the denominator, so I have reduced it to lowest forms. Number 4 is one that isn't unusual. When we have mixed numbers, we always make our mixed number into an improper. We do that by multiplying the whole number times the denominator, and we add the numerator. So that is 2 times 8 plus 5, and of course we keep the same denominator. So 2 times 8 is 16, plus 5 gives me 21 over 8. 4/7 is a fraction. We'll keep that. And then 16 over 1, whenever we multiply by a whole number, we need to make it look like a fraction. So we simply throw a 1 underneath that. It doesn't change the value. 16 divided by 1 is 16. 16 single pizzas is 16 pizzas. So we'll keep the 16 as 16 over 1. Now, I really don't want to have to multiply 21 times 4 times 16, get an answer, and then reduce. So what I'm going to do is I'm going to look around here to see if there's something I can do to cross-reduce before I get a large number. Well, I see common factors in the 7 and 21. So I will divide 7 by 7. I get 1. Put 7 into 21. I get 3. I'm going to use some color here. And then I look at my 4 and my 8. Well, 4 will go into 4, and 4 will go into here. So 4 divided by 4 gives me 1. 4 divided by 8 gives me 2. Now I can go ahead and multiply. I've really knocked this down quite a bit. But I see I have a 2 and a 16. I can use this 2. So I'm going to put 2 into 2, and I'm going to put 2 into 16 and break it down even more. So I'm going to go 2 and 16. 2 divided by 2 gives me 1. 2 goes into 16 8 times. I look at it, there's no other way that I can cross-reduce, so I'm just going to go ahead and multiply my numerators. 3 times 1 is 3, times 8 is 24. 1 times 1 is 1, times 1 is still 1. This is improper, and if I think of it as 24 divided by 1, I get 24, my final answer. Division is exactly the same as multiplication, except of a first step. We always flip, invert, reciprocate our divisor, which is our second fraction, and we multiply. So my first one stays the same, 25 49th stays exactly as it is, and then I flip, reciprocate, invert 5/7, so it becomes 7 over 5, and multiply. The rule for division says let's invert the second fraction and multiply. So it's multiplication now. All my rules that we just talked about with the multiplication of fractions holds true. So I'm going to look at my 7 and my 49. Well, I see that I can put a 7 into both places evenly. 7 goes into 7 once. 7 goes into 49 7 times. And then I look at my 5 and my 25. Well, 5 is a factor of both. So 5 divided by 5 gives me 1. 25 divided by 5 gives me 5. So now I'm going to take my new numerator 5 times 1. Denominators 7 times 1. I look at my 5/7. 5 will go into 5, but it won't go into 7 evenly. The only thing going into 7 is 7, and that won't go into 5 evenly. So it is reduced. My final answer is 5/7. Hope that helped. Keep practicing. Watch the other videos to just give you more, another way to look at it. So good luck.